In the end of our last video, we look into an example of the database applications through the company database. We looked the database description regarding to the employee, department, project, and the dependents in English description. So the continued part of the database ER diagram design is going to be look into the entity part as well as the relationship part. Before we even move into the entity part, which is going to be the main focus of this video, let's take a look of the end product. Based on those descriptions, we actually will end up with this pretty big figures. This is what we talk about the entity relationship diagram, ER diagram. You can see that there are employee, which is one of the entities we described, department, project, as well as dependent. There are many attributes talking about each of the entity, and there are relationships that connects different tables together. So this is what we want to learn. How do we convert those descriptions in English into what we call a conceptual design of the database ER diagram? In this figure, you see that there is actually no code, obviously. This is what I talk about, the pseudocode for the database description. We want to understand this part first before we can even start writing the program. So let's start looking into the entity part. Start with the oval shapes, which are the attributes describing the entity. The example of the relation, basically each entity is a table. In the table, there are some formal terminologies that we want to use. So basically you can see in this example, student is the student table that we are looking at. Basically, we also give it another name instead of the table name. It can also be referred as relation name. Attributes, each column are describing different attributes of the relation or the students that we want to talk about. Each row represents one student. So this is the basic idea of the ER model. And of course, student can be considered as one rectangular box we see in our previous slide, and then each attribute can be considered as an oval, which are the attribute describing the student entity. The most basic objects that the ER model represents is an entity. An entity may be an object with physical existence, such as a person. You can see a person, a car, a house, so that if you look into the websites describing the house, then obviously you need to look into how many bedrooms that you have, what's the address, how many square feet this house have, does it have a garage, those kind of things. You can see those are the attributes describing the house. So it can be something real existed, or it may be an object with conceptual existence, such as a company, a job, or a course. So you cannot really see that. You can do that, you can use it, you can be there, but you cannot really see it. So basically that is like human creation, creates a conceptual existence of an item, and we try to describe it. So for example, courses, how many students do you have? Which room are you going to use? What is the time, etc. Waiting list. And every entity has attributes. We have talked about many different examples. The particular properties that describing the entity you are interested in. So we would start looking into the entity part, mainly focus on the attributes. To talk about the attributes, there are several different types of attributes, and we want to understand it. So this is a list of 5 different types of attributes that we want to look into. First of all, simple versus composite attribute. Then single value versus multi-value attribute. Then we will look into store versus derived attribute, a null attribute. Right now, you should already have some idea about the null since you pass CS1, CS2, even the data structures. In database, null can be have additional meanings besides the null that you already know. So that's something we want to look into. Finally, a complex attribute is a combination of the composite attribute and multi-value attribute. Since two things combined together become very complicated, and that's why we call it a complex attribute. So let's take a look of each one by one, and then you can have better understandings about what are the attributes. First of all, composite versus simple attributes. So what is it? Composite attributes can be further divided into smaller parts. That is something we call a composite attribute. For example, the best one is the address. Your address is consists of the street name, street number, city, state, zip code. Sometimes you have even more, apartment number or something extra. So one attribute of the address can be further divided into smaller subparts. When this type of attributes describing an entity we are interested in, we then call this as a composite attribute. Think about this. When you try to apply a credit card or you go to Amazon and try to buy some, when you try to fill in the address, does it give you one big box of address and you fill everything, or it has nicely separate everything into smaller parts, including the streets, number, street name, city, zip code, state? They usually are separated. And that is the exact idea of the composite attributes being implemented in our real life. Same thing with your name. Rarely, it still have some cases that they give you a big box of the name, so you type in your name, Bernard space Chen, but most of the case, they have separate into first name, middle name, and last name. And that is another good example of what we call a composite attribute. On the other side, if the attribute cannot be further divided, such as your first name, your salary, it doesn't make sense that you try to separate your salary into two bucks. Okay, gender as well. So these are the type of the things are considered as the simple attributes. Most of the attributes that we try to describe is simple attributes. Occasionally, we will go into a more complicated format, which is going to be the composite attributes. Well, of course, this is depending on the real examples, real life examples that you are facing. The value of composite attribute is the concatenation of the value of its constituent simple attributes. What does that mean? What that's trying to say is this. You can see the address can be further divided into street address, city, state, and zip. When that is happening, your street address plus city plus state plus zip equals to your address. So these four things combined together equals to your address, one thing. You can, sometimes there's hierarchies over there, you can further divide your street addresses into number, street and apartment number. Needless to say, number plus street plus apartment number equals to street address. And therefore, to represent this in the ER diagram, you can see that for a composite attribute, for the level of street, city, state, zip code, what's going on is that the address is equal. By this representation, you can see streets is equal to, address is equal to street plus city plus state plus zip. If we go into the higher level of that, this is how we are going to present. The street is equal to number plus street plus apartment number. And therefore, these are the things that we try to describe the composite attributes. Let's take a look of another example. For the department, there's a name for the department. So we use an oval and a line connecting to an entity, and of course, we are using a rectangular box to represent an entity. Versus, for a name to describe an employee can be further divided into first name, middle name, and last name. Department doesn't need that, but for employee, the name is usually consists of those three parts. And therefore, this gives you another example to understand what is a composite attribute. Now, let's take a look of the next one. Single value versus multi-value. So if the attribute try to describe a single value for a particular entity, such attributes are called single valued. For example, salary. Salary is a simple attribute as well as a single value attribute. The same thing with gender. Okay. In some cases, an attribute can have a set of values for the same entity. For example, color attributes for a car. Sometimes a car, most of the time a car has only one color, but I believe you have seen some pretty fancy cars that it has black in the color, and there in the middle of the car there's like this white strap lines go from the front bumper to the end bumper. So there are two colors of it. To describe it, it will be black and white. Most of the time, cars describing as black, white, yellow, blue, etc., red. But for some cases, as long as there are some cases that you need to handle, then when you try to design this attribute, you have to design it as a multi-value attribute to make sure when some special cases happens, your database can handle that. Another example is the college degree. Most of people have, if they have college degree, they have one college degree, but there are people who do double majors. So in that case, the college degree would be more than one or triple majors. So if you understand that attribute has some occasions that will need to hold more than one value, then you need to make it as a multi-value attribute. Such attributes are called a multi-valued. A multi-value attribute may have lower and upper bound to set this to allow for each entity. Think about this. Why do we need to stand aside and then look into a multi-value attribute? I want you to refer that question back to CS1 or CS2. When you create a variable, say int I, how many values can I hold? 1, right? When I equal to 1, I is equal to 1. When you see I equal to 5 and I is equal to 5, it cannot be 1 and 5. That's exactly what's happening in back of the database. When you're creating a variable holds one value. If there are some cases that you need to have more than one value to be held by the variable, then that cannot simply be a variable anymore. It needs to be creating something like an array that can hold multiple values over there. And that is why we need to separate it out to look into what we call a multi-value attribute. Let's take a look at some examples. Project, remember that when we were looking into the example, each project has a unique name, number, and is located at a single location. So when we're looking into the project attributes, which is the location, we have only one location. However, a department may have several locations. When we were looking into the department description, since it can have multiple locations, we need to specify it as a multi-value attribute. To describe it as a multi-value attribute, we'll put double ovals on the attribute, indicating that is a multi-value attribute. So you need to understand the difference between composite attribute and multi-value attribute. For address, because it can be further divided into two smaller parts, then that is what we call composite attribute. It still has, for address, in terms of the address, Address can be further divided into smaller parts, but you only have one address. So that is a simple value. It is a single value composite attribute. For locations, since you can have multiple locations over here, then this is going to be a multi-value attribute to describe it. But since location holds only one data, it cannot be further divided, and that's what this is what we call the multi-value attribute and a simple attribute. Remember, in the beginning of the slides, we talked about it. It's what we call a composite attribute plus a multi-value attribute. That's like the worst nightmare that combines the two things together. We will save that to the last, which is going to be described as a complex attribute. Let's continue with stored versus derived attribute. This is much easier. In some cases, two or more attributes are related to each other. For example, birthday and age. Think about this. If you are designing a database, you need to keep track of a person's age. You also need to keep track of a person's birthday. Which one is it that how would you want to handle that? First choice, you can have a birthday attribute and an age attribute. When that's happening, I need you to understand what is going on. That means when you create a birthday attribute and when you when you have a person that want to enroll into the employee, you need to hand type in their birthday, which is fine. How about the age? Age will change all the time. So if you create one regular attribute, you need to put in the person's age. When every year comes to his birthday, you need to go back into the database and change his age. That is what we call a stored attribute. And that doesn't seem easy for anyone to do that. If you already have a birthday, you better want to derive their age based on today's date. And therefore, we will have a stored attribute of the birthday, and using that, you can derive their age. So the age will be derived attribute. And this is derived from the birthday. So the address attribute is derived attribute, and it's said to derive from the birthday attribute, which is called a stored value. Whenever you design a derived attribute, make sure you know how is this value being derived. You must have some stored value that you will be able to work with and then calculate this value. Here's the example. Employee. So if you have a birthday, we use age in a dash oval, indicating that is a derived attribute. Make sure you understand this. Some students will make this derived attribute, draw it, have a line over the birthday, and then have a dash line over the age over here. It is incorrect, because what that's trying to say is saying that the age attribute is birthday attribute using the composite attribute concept. So don't do that. You simply need to create a separate independent one of a derived attribute, age. When we comes to the implementation, you will understand that we are not really going to do the age attribute, create the age attribute for the employee. We will leave that as a function purpose. Remember, when we're designing a database, we need to look into the data description as well as the function description. So that is what we will do. Another example is this one, department, because we will have a relationship between employee and department, indicating that which department that each employee works for. And therefore, we can derive number of employees for the department. Now let's take a look at the null value. In some cases, a particular entity may not have an applicable value for an attribute. For example, apartment number. Most of the time, we don't have an apartment number. College degree. Not everybody has a college degree. So when you trying to create a box over there, sometimes for this kind of things, you need to make sure it is okay to leave it null. Come back to your online shopping experiences. When you're ready to check out, there's usually a lot of box for you to input your name, your address, etc. Those boxes with a star sign on top of it usually represents that you have to put something. For the box that without a star sign, indicating you can leave it blank over there, so that if you don't put anything over there and you hit proceed, you can successfully move on. And everybody has experiences that if there is a box with a star sign and you didn't put anything over there, when you hit proceed, it will say, hey, here is something that you need to fill in. So think about this. Just use that as an example. When a database person sees that a block over there without information in it, there's two possibilities, and that's what I want to talk about, the null values. One is that they really don't have the value, the apartment number, for example. The second one is that the user is just too lazy to put in any value. Don't think that's a bad thing. You and me both do that kind of things all the time. If there's no star sign, I'm not going to put in values in that box. So null can also be used if we do not know the value, so that there are two meanings of the null value. The meaning of the formal type of null is not applicable, which means that they really don't have it. The other one is maybe there is a value in that, but we just don't know about it. So it can be not applicable or it is unknown. That is the null meanings in database. Finally, complex attribute is a combination of multi-value attributes and composite attribute. So for example, if a person can have more than one residence, and each residence have a single address and a multiple phones, so that is going to be an example of the case of that. And you can see that if we have a person has an address, so the address can be further divided into street, city, state, and zip code. Maybe that is the address for your university address. There's also another address that you use representing the home address. Similar things about the email. So email can have the email account, and after the @ it can be uca.edu. It can be divided into two parts. On the other side, if that is a Gmail account that you have, so you can have your account name at gmail.com, so that it can be further divided, and you can have multiple values of that. That gives you a complex attribute. So you can see it's a combination of multi-value attribute and composite attribute, which is the most complicated form of the attributes that we can have. Here is another example. So the address can use the more detailed descriptions by looking into the number, street, apartment number over the street, so that the address, if we do this, you need to understand one thing. The address become number plus street plus apartment number plus city plus state plus zip. So there are 6 attributes describing the address. And since you can have multiple address, this forms a complex attribute.